Hi, my name is Jawab Hamidirad, and I work at Interdigital AI Lab. Here we are demonstrating the interdigital technology about split squeeze computing. So when you're running the distributed applications, you need to balance between many important parameters like energy consumptions, bandwidth consumptions, and the latency and the speed that you're running your application. So interdigital split squeeze computing allows you to balance all of these parameters. Let's consider a natural disaster scenario when you want to send drones equipped with cameras to the field and try to find survivors in that, in that scenario. So there are multiple ways to implement this. The easiest way is to use a local device, everything running on the drone, and you get the camera, go to machine learning algorithm, and it detects survivors in the captured frames. This uses a lot of energy and runs out of the battery quickly. So this is not the ideal situation, using everything locally. One solution is to use the remote server. We are sending the whole video compressed. We don't have a lot of power considerations here because it is plugged in. And usually these devices are very powerful. So this saves us a lot of energy on the local device, and you can run much longer. Your drone can be up in there much longer. But the problem in that is that it uses a lot of bandwidth when you're sending the video from the local device to the remote server. Interdigital suggests a middle point between these two extremes. So we are splitting the neural network and running one part of it on the local device and the other part on the remote server. And this allows us to find a middle point between the consumptions on the device and also the bandwidth that we are using. This solves the problem about the battery, but it increases the bandwidth because these features use a lot of bandwidth to transmit. So the solution for that is to compress the features that are being sent from the local device to the remote server. Interdigital is one of the main contributors to the MPEG FCM that is trying to standardize how these features are compressed. We are using that technology here to reduce the bandwidth, and this can be done very efficiently, and your bandwidth can be much lower than what you had when you're sending the compressed video. The applications is, as I mentioned, the search and rescue with drones. It can be used in smart factories and factory automation. And it also has application in resource-limited devices when we want to do autonomous navigation.